Good day everyone. So in this video, we were given a task to record at least 2 items from number 1 and 2, 1 item from number 3 and 4, and at least 2 questions from number 5 to 8. So let's start with number 1. In number 1, find the value of the 6 trigonometric functions of the angle theta in each figure. So we have here a problem A. In problem A, we have opposite and adjacent. So, to find the hypotenuse, we will use Pythagorean theorem since it is a right triangle. So, let A be the opposite and let B be the adjacent. So, we have A squared plus B squared equals C squared. Then substitute, we have 3 squared plus 4 squared is equal to C squared. So 3 squared is equal to 9 and 4 squared is equal to 16. Then copy the C squared. So 9 plus 16 is equal to 25. Then copy the C squared. Then square root the 25 and C squared. So the square root of 25 is 5. So therefore, the hypotenuse is 5. At this time, let's find the value of 6 trigonometric functions. So first is we have sine theta is equal to 3 over 5. Cosine theta is equal to 4 over 5. Tangent theta is equal to 3 over 4. Cosecant theta is equal to 5 over 3. Secant theta is equal to 5 over 4. And last is cotangent theta is equal to 4 over 3. Next is the problem E. So in problem E, we have hypotenuse and opposite. So to find the adjacent, we will use Pythagorean theorem since it is a right triangle. So let A be the opposite and let C be the hypotenuse. So we have A squared plus B squared is equal to C squared. Then substitute, we have 1 squared plus B squared equal to square root of 5 squared. So 1 squared is equal to 1. Then copy the B squared. Then cancel out the square root and the squared. So we have 5. Then transpose the number 1. So we have B squared is equal to 5 minus 1. So B squared is equal to 4. Then square root the B squared and the number 4. So we have B is equal to 2. Therefore, the adjacent is 2. Then next is let's find the value of the 6 trigonometric functions. So first is we have sine theta is equal to 1 over square root of 5. Then rationalize. So we have 1 square root of 5 times square root of 5 over square root of 5. So we have square root of 5 over square root of 25. Then copy the square root of 5. Then the square root of 25 is equal to 5. The next is cosine. So we have 2 over square root of 5. Then rationalize. So we have 2 over square root of 5 times square root of 5 over square root of 5. So we have 2 square root of 5 over square root of 25. Then next is we have 2 square root of 5 over square root of 25 is 5. So we have 5. Next is tan theta. So we have 1 over 2 or 1/2. Next is cosecant. So we have square root of 5 over 1. Next is secant. So we have square root of 5 over 2. And last is cotangent. So we have 2 over 1 or 2. Now let's proceed to number 2. Use the definition or identities to find the exact value of each of the remaining 5 trigonometric functions of the acute angle theta, which is cosine, tangent, cosecant, secant, and cotangent. So we have here a problem A. Sine theta equals square root of 2 over 2. So we find first the cosine theta. So in cosine theta, we use Pythagorean identities. So we have sine squared theta plus cosine squared theta equal to 1. Then substitute. So we have square root of 2 over 2 squared plus cosine squared theta is equal to 1. Then copy the cosine squared theta equal to 1. Then transpose. So we have negative square root of 2 over 2 squared. Then copy cosine squared theta is equal to 1 minus square root of 4 over 4. Then copy the cosine squared theta, then 1 minus 2 over 4. Then copy the cosine squared theta, square the cosine theta, and 2 over 4. So we have square root of 2 over 2. Next is the tangent. So in tangent, we use quotient identities. So we have tan theta is equal to sine theta over cosine theta. Then copy. Then substitute. We have square root of 2 over 2 over square root of 2 over 2. Then copy the tan theta. Then we have square root of 2 over 2 multiplied multiplied by 2 over square root of 2. And copy. So we have 2 square root of 2 over 2 square root of 2. Then rationalize. So we have 2 square root of 2 over 2 square root of 2 multiplied by square root of 2 over square root of 2. So we have 2 square root of 4 over 2 square root of 4. So we have 2, then square root of 4 is equal to 2 over 2 square root of 4 is equal to 2. So we have 4 over 4 or 1. So tan theta is equal to 1. Next is the cosecant. So in cosecant, we use reciprocal identities. So we have cosecant theta is equal to 1 over sine theta. So copy. Then we have 1 over square root of 2 over 2. Then copy. So we have 2 over square root of 2. Then rationalize. So we have 2 over square root of 2 multiplied by 2 square root of 2 over square root of 2. So we have 2 square root of 2 over square root of 4. Then we have 2 square root of 2 over 2. So we have cosecant theta 2 square root of 2 over 2. Then divide it into 2. So we have cosecant theta is equal to square root of 2. Next is the secant. So in secant, we use reciprocal identities. So we have secant theta is equal to 1 over cosine theta. Then substitute. So we have secant theta is equal to 1 over square root of 2 over 2. Then copy. So we have 2 over square root of 2. Then rationalize. So we have 2 over square root of 2 multiplied by square root of 2 over square root of 2. So we have 2 square root of 2 over square root of 4. Then copy that 2 and square root of 2. Then the square root of 4 is equal to 2. So therefore, the secant is equal to 2 square root of 2 over 2. Then divide it into 2 or cancelled out. So we have secant theta is equal to square root of 2. Last is the cotangent. So in cotangent, we use reciprocal identities. So we have cotangent theta is equal to 1 over tan theta. So we have cotangent theta is equal to 1 over 1 or cotangent theta is equal to 1. Next is we have problem B. So in problem B, we have tan theta is equal to 1/2. So we find first the cotangent. So in cotangent, we use reciprocal identities. So we have cotangent theta is equal to 1 over tangent theta. Then copy. Then substitute. So we have 2 over 1. Or cotangent is equal to 2. Next is the second. So in second, we use Pythagorean identities. So we have 1 plus tangent squared theta is equal to secant squared theta. Then substitute, so we have 1 plus 1/2 squared equals secant squared theta. Then copy the 1 plus 1/4. Then copy the secant squared theta. So 1 plus 1/4 is equal to 5 over 4. Then copy the secant theta. Then square root the 5 over 4 and the secant squared theta. So we have square root of 5 over 2. So therefore, the secant theta is equal to square root of 5 over 2. Next is the cosine. So in cosine, we use reciprocal identities. So we have cosine theta is equal to 1 over secant theta. Then substitute. We have 1 over square root of 5 over 2. So we have 2 over square root of 5. Then rationalize, so we have 2 over square root of 5 multiplied by square root of 5 over square root of 5. So we have 2 square root of 5 over square root of 25. So copy the 2 and square root of 5. Then square root of 25 is equal to 5. So therefore, our cosine is equal to 2 square root of 5 over 5. Next is the cosecant. So in cosecant, we use Pythagorean identities. So we have 1 plus cotangent squared theta is equal to cosecant squared theta. So we have 1 substitute, so we have 2 squared is equal to cosecant theta, cosecant squared theta. Then copy. So 2 squared is equal to 4. Then copy. 1 plus 4 is equal to 5. Then square root the 5 and the cosecant. So we have square root of 5 cosecant theta. So therefore, cosecant theta is equal to square root of 5. Last is the sine. So in sine, we use reciprocal identities. So we have sine theta is equal to 1 over cosecant theta. Then copy. Then substitute. So we have 1 over square root of 5. Then rationalize. So we have 1 over square root of 5 multiplied by square root of 5 over square root of 5. So we have square root of 5 over square root of 25. Then copy the square root of 5. Square root of 25 is equal to 5. So therefore, the sine theta is equal to square root of 5 over 5. Next is number 3. Given sine 30 degrees equal to 1/2, use trigonometric identities to find the exact value of cosine 60 degrees. So we will use cofunction identities. So we have sine 30 degrees equal to cosine 90 degrees minus 30 degrees. Then next is copy the sine 30 degrees. Then subtract the 90 degrees and 30 degrees. So we have cosine 60 degrees. So the cosine 60 degrees is equal to 1/2. Next is number 4. Simplify each expression for the given value of x. Assume the angle theta is acute. So we have here a problem A, which is square root of 25 minus x squared. So the given is x equal to 5 sine theta. So first is we need to substitute. So we have here a square root of 25 minus 5 sine theta squared. Then 5 squared is equal to 25. So we have square root of 25 minus 25, then sine squared theta. Then apply the Pythagorean identities. So since sine squared theta is equal to 1 minus cosine squared theta, so we have here a square root of 25 minus 25, then 1 minus cosine squared theta. Then next is we will use distributive property. So we have square root of 25 minus 25 plus 25 cosine squared theta. Then 25 minus 25 is equal to 0. So copy the 25 cosine squared theta. Then cancelled out the square root and the squared. So we have the square root of 25 is equal to 5. So we have 5 cosine theta. Next is number 5. At a certain time of the day, the angle of elevation of the sun is 40 degrees. To the nearest foot, find the height of a tree whose shadow is 35 feet long. So to find the height, we will use tan theta is equal to opposite over adjacent. So first is we need to substitute. So we have tan 40 degrees is equal to height over 35. Then multiply each side to 35. Then cancelled out the 35. So we have 35 tan 40 degrees is equal to height. So the value of tan 40 degrees equal to 0.8 0.839099631. Then copy the height. So 35 times 0.839099631 is equal to 29.37. So the height is 29.37. And last is number 6. A tower that is 125 feet long cast a shadow 172 feet long. Find the angle of elevation of the sun to the nearest degree. So to find the acute angle, we will use tan theta over opposite is equal to opposite over adjacent. So next is we will transpose the tan. So we have theta is equal to tan to the power of 1. Then copy the 125 over 172. So 125 divided by 172 is equal to 36 degree.